Okay, so climatograms, guys, are basically a graph that tells us the temperature and the precipitation for a specific location, okay? And they graph it by month. So not only does it tell us certainly precipitation and temperature numbers, but it's also going to give us a pretty good idea of things like latitude, altitude. It's going to, at least, those are the things that are going to affect the shape of a climatogram. Okay, so when we're looking at, let's say, this one here that is for Manokwari, New Guinea, okay, this is basically like sitting right on the equator. All right, now, we said yesterday that latitude really affects your climate, but if you're near the equator, the angle of the Earth doesn't really affect the quality of the sunlight you get. You guys remember that from yesterday? Okay, so what's not going to change throughout the year for you if you are near the equator? Okay, amount of light, and the thing that's most related to amount of light weather-wise would be temperature. Okay, and you can see here that on this climatogram, okay, the line going across, and by the way, the line represents the temperature, the bars represent precipitation. Okay, we can see that temperature pretty much doesn't fluctuate at all. Okay, it's pretty much the same all the way across. Now, when we look at rainfall, on the other hand, we see that rainfall does fluctuate a bit, but it is still generally pretty what? High or low? Okay, this is the rainfall side of the climatogram over here on the left. Okay, and you can see that they measure their rainfall in centimeters. That's a lot different than what we measure precipitation in. Okay, I mean, we measure snowfall in centimeters, but when you melt snow, about 10 centimeters of snow amounts to less than a centimeter of rain. Okay, because when snow collects on the ground, it's mostly air. Right, that's why it's such a good insulator. So we got their wettest month is 33 centimeters of rain. That's that much in a month. Okay, we get that much in like a year. Well, probably not, but we maybe get this much in a year. Okay, they would get that in a month and a half. Right, so it's certainly a lot wetter there than it is here. Okay, I mean when we had the big floods. Okay, we got around, I think that would have been about 18 to 20 centimeters of rain. Okay, and now we got it in a space of like 2 weeks, right? But look what happened. Okay, our landscape and stuff is just not used to that kind of rainfall. So when it happens, bad things go on. Okay, whereas in a place like New Guinea, it happens all the time. Right, it's kind of a constant state of flooding for them. All right, so we can see here that rainfall is generally pretty high, but okay, temperature is pretty steady. Now, you can see in these other two that the temperature makes a bell curve, which means it fluctuates. Okay, if we see a bell curve, that means that there are seasons. Okay, you really don't have seasons other than maybe wet and dry. Okay, in the tropics, you might have a wet season and a dry season. We can see that here with New Guinea, right? This would be kind of their dry season in here, and this would be their wet season, okay, over here. But they don't really have summer, winter, fall, spring, okay? Well, not that we have fall or spring usually either. We can have summer and winter, but okay, you get the idea, okay? We get definite changes in temperature because we get changes in light. We get changes in intensity of light. We get changes in amount of light, right? So we get this bell curve that shows certainly there are warmer months, and there are colder months. Now this is Nashville, Tennessee. So that's down kind of in the central part of the United States towards southern part of the United States, right? It's certainly a lot warmer than here, but they still have definite seasons, right? Now their coldest month is about 4 degrees Celsius on average, and their warmest month is about 28 degrees on average. Okay? And their rainfall is pretty steady. It's not nearly as high as the tropical rainforest, but it's pretty steady. They get around, let's say, 8 to 12 centimeters of rain in a month. So about that much, right? Pretty reasonable. Now, the further north you go, you can see that the bell curve does what? It drops. This is Anchorage, Alaska. Okay, I mean, that's pretty far north, right? So the bell curve is quite a bit lower. It's still a bell curve. They definitely have seasons because they're far from the equator, but okay, showing here, coldest month, -10. Okay, warmest month, about 14 degrees Celsius. Okay? Anchorage is also close to the ocean, so the ocean regulates its temperature quite a bit. If you're looking at like kind of more inland in Alaska, like if any of the ones you watch on like the Discovery Channel or National Geographic, they got all those Alaska shows. Okay, those are usually much further inland and much colder. Okay, all right, everybody with me here? Making sense? Okay, and we can see here precipitation is pretty low. Right? I mean, we're looking at their wettest month having 8 centimeters of precipitation. Okay, now why is it so low through here? January, February, March. Precipitation is not falling as rain, it's falling as snow, and it doesn't hold as much moisture. Okay, I mean, we look outside and we're like, well, man, we got all this snow, but I said again, it doesn't really add up to a lot of water. Okay, so we have to consider that when we're measuring how much precipitation. It's always measured in equivalents of water, not in snow. That's why Antarctica is the driest continent. Okay, it's covered in ice. Okay? It has more fresh water than any other continent in the world, but it's frozen. Okay? It never gets any liquid precipitation. All right, so is everyone following how these work? Okay, so when we look at the shapes, that can tell us some things about it. Okay, the higher the precipitation, okay, generally we're looking at, probably at, close to an ocean or very tropical kind of area. Okay, and the shape of the bell curve and the location of the bell curve tells us how cold and how far from the equator that place might be. Yeah. All right, so we'll pause here. Okay, well, if you're not signed in, it's not too important for you to be there yet. Okay, we'll just do a little bit of explaining here. Okay, what we're trying to investigate with this activity is what factors are most important or most affecting, in general, cities in Canada. Okay, so the way we're going to do this is on that Google Sheets, or Google Docs, sorry, document that I gave you, I have the climate graphs for many Canadian cities. Okay, well, as many as I could find of them, they're on there. Okay, what we're going to do is we're going to look at those climate graphs, and based on their numbers, that is precipitation and temperature, okay, as well as similarity in shape and pattern, we're going to try and put cities together in groups. Okay, just based on the shape of those climate graphs. Okay, so we'll look at them and we'll go, okay, like these two cities, their temperatures seem to be quite mild, and their precipitation seems to be pretty high. I'm going to put them together in a group. These cities here, their temperatures are really bell curved. They seem to be really low when they're in the wintertime, but really high in the summertime. They don't get a lot of precipitation, and there's 3 or 4 cities that are like that. I'm going to put them in a group together, okay, without even really looking at the names, just looking at the numbers, putting them in groups. Okay, once you've got all the cities in groups, then you're going to look them up on Google Earth. Okay, see where they're at, and see if they have any factors in common. Okay, now when you do that on Google Earth, if you actually click on things, it'll give you the latitude and the longitude. You don't really need the longitude, okay, but it'll give you the latitudes right off. If you just click on, if you go into Google Earth and click on the spot, it'll give you latitude and longitude. All right, so you can look at the latitudes and see if they're similar. Okay, if they are, then you can say, well, they're similar latitudes. Look at what they're near. If they're both near the ocean, well, okay, then obviously ocean is a factor that affects climate. Maybe they're all right along the Rocky Mountains. Oh, well then maybe the main factor affecting their climate is proximity to mountain barriers, or things like that. That's what we're going to be looking for. Does everyone kind of follow there? So we're going to put them in groups based on their shapes and patterns. Then we're going to look them up and see what they really have in common. Why are they similar in climate? Are there factors that affect all of them in similar ways? Okay, once we've done that, then we'll come up with names for those groups. Okay, so you might have like an Atlantic climate and a Pacific climate and a prairie climate or whatever. You can decide, however you decide to group things together is your decision entirely. Okay, everybody with me there? Right? Do you see the climate graphs there that are down below? Okay, they probably look like this. Okay, it's these same ones. All right, so we've got them like this is for Halifax, this is for St. John's, Prince Rupert, okay, Charlottetown, okay, all those kind of things. So they're all in there. All right, so you're gonna get together in groups. It's always easier to kind of bounce ideas off of each other when you're doing this grouping thing. Okay, you don't have to construct the climate graphs; they're on there for you. Okay, so you don't have to worry about that part. I think actually I deleted that off of yours anyway, didn't I? That step isn't in your procedure. Okay, so in an atlas, you'll locate those cities. We'll use Google Earth because it works just as good. Okay, as well as Vancouver, Medicine Hat, and St. John's. Okay, write a brief description of each area. Okay, so for all the places that have a climatogram on there, okay, when you look at Google Earth, write a description of that place. You know, in the middle of the prairies, or right on the mountains, or next to the ocean. Okay, and a few other things, like anything that you think is important that could affect its climate. And then you can look at the ones you've put in groups together and say, hey, look, I wrote kind of the same thing for all of these. So the major factors affecting climate for these cities are these factors. They're all going in this group together. Okay, you guys follow me there? Right, so that's what we're trying to do. And we're going to see if there's kind of anything in common or any patterns. Right? Yes, yeah. Okay, now your hypothesis, okay, just needs to be a tentative answer to the problem. So if, name some factors, okay, affect climate, and we compare a bunch of Canadian cities, then it'll be found that, you know, cities with these things will end up in the same group. Okay, or something like that. It's going to go something like that. The if part needs to talk about what factors you think are going to be most important. Okay, the and part is what we're doing, comparing climate of Canadian cities. Okay, and the then part is basically any patterns you're going to see. Okay, so with your group, like we said, you're going to group you're going to have all the cities in groups, and then you're going to see what kind of things they have in common. Give a reasonable name to that group. Okay, and the examples I have up here are Atlantic climate, mountain climate, polar climate, whatever names you think are appropriate. Okay, as an answer to this discussion, okay, discuss the effect of latitude, large bodies of water, ocean currents, surface features, okay, things like that. Right, you can look all of that stuff up. Okay, in with your Chromebooks there, you can look up, you know, are there ocean currents near Atlantic coast, and you can see if there's anything in common there. Okay, or ocean currents near Pacific. You can do all of that stuff rather than get an atlas. I find that an atlas really stifles people. Okay, because they're always, you know, there's so many different kinds of maps, right? I mean, there's even maps about socioeconomic statistics in there. It just doesn't. I just find they don't get you what you're looking for quickly. Okay, whereas an internet search will. Right. And I think Google Earth is also another good one to use. Okay, the things you should put in a description of each city: latitude, altitude, okay, and then any other factors that you think are important. Okay. Once you've got them in groups, then you'll say, all right, these groups are all high, or these cities are in the polar climate because they're all very high latitude and they're far away from bodies of water, blah, blah, blah. Okay. Question number 2 is use Google Earth, look up these cities. Based on where they are, put them in the groups you made in question 1. Okay, with justification. This one's going in this group because, this one's going in this group because, and so on. Okay? Questions on what you're doing? Okay, and I really do suggest that you work together with somebody else, because sometimes someone sees a pattern that you don't see. It's really good to be able to bounce ideas off of each other. In the end, you're still handing in your own lab report, but it's always good to have 2 heads are better than 1. 3 heads are better than 2. But after that, things break down. Okay. All right. And then your conclusion, basically, when you get to there, okay, what patterns did you see? Okay, based on your groups, okay, were there patterns, okay, of factors affecting climate, okay, that seem to make similar, have some cities have similar climates, etc. Okay. All right, questions on that? All right, so you guys will get almost a half an hour, okay, to work on that today, and well, it's a half an hour you don't have to spend later. The day we come back, we're also working on this. All right, so you have that full class as well. You'll probably get finished, I would think, in that class, so don't spend any time working on it over Christmas. Okay, that is not the expectation. All right. Okay, so yeah, when you are looking at this, guys, you do need to have, I would say, a minimum of 5 climate groups. Okay, I've had people who like have two, and that's just simply more than that. Okay,